Hi, welcome to this Corbettmaths video. In this video, we're going to go through the video solutions to the perpendicular lines practice questions. If you need any extra help on perpendicular lines, feel free to go to corbettmaths.com/contents and scroll down to video number 197. And there you'll find a dedicated video tutorial to perpendicular lines. Alternatively, scan this QR code and that'll bring you straight to that video. In this video, though, we're going to go through the video solutions to the practice questions, so let's get started. So question number one. Question number one says, write down the equation of a line that is perpendicular to y equals 2x plus 3. So we've got the equation of a line, y equals 2x plus 3, and we want to write down the equation of any line that's perpendicular to that line. So remember, whenever two lines are perpendicular, their gradients will multiply together to give you -1. Or another way to consider is the gradient is the negative reciprocal, and I'm going to use that in this video a lot. So here we're going to have y equals, and for our line that's perpendicular to this line, the gradient of this line is 2, so we want to find the negative reciprocal of 2. So the reciprocal of 2 is a half, so the negative reciprocal would be -1/2. So the gradient of the line that is perpendicular to this line would be -1/2. And then we're going to write our x, and then we just need to write the equation of a line that's perpendicular to this one. So we could just write that, y equals -1/2x, or we could put something like +20 or +4 or -1 or whatever, any line at all. But any line at all that has got the gradient of -1/2 would be perpendicular to this line. And that's it. So let's just write our answer in, y equals -1/2x plus 20. And that's it. Okay, let's have a look at our next question. Question number 2. Okay, let's have a look at question number 2. So question number 2 says, write down the equation of a line that is perpendicular to y equals 1/2x plus 3 and passes through the point 0, -1. So this time we're trying to find the equation of a line that is perpendicular to this line, but also passes through this point. Okay, so let's consider our perpendicular line. So it's going to be y equals mx plus c. It's a straight line, so it'll have that equation. So it's going to be y equals, in terms of its gradient, the gradient of the line we've been given is 1/2. Now the gradient of the perpendicular line, well, the two gradients will times together to be -1, or we can consider the negative reciprocal. So the gradient of this line is equal to 1/2. The reciprocal of 1/2 would be 2, so the negative reciprocal would be -2. So it's going to be y equals -2x, so that's the gradient of the line, -2, so y equals -2x. Now in terms of the c, remember the c is the y-intercept, is where the graph crosses the y-axis. Now this point is really nice because that is, if we consider our x and y-axis, our x-axis and our y-axis, the point in 0, -1 would be 0, -1 it would be there. That is where it crosses the y-axis at -1. So that means that the y-intercept is -1. So the equation of the line would be y equals -2x minus 1, and that's it. Okay, let's have a look at question number 3. Okay, let's have a look at question number 3. So question number 3 says a straight line passes through the point 0, 8 and is perpendicular to y equals -4x minus 3. And we've been asked to find the equation of the line. That's a straight line, so it's going to be y equals mx plus c. And we just need to find m, the gradient, and c, the y-intercept. So let's start off with the gradient. The gradient of this line would be equal to -4 because y equals -4x minus 3, so the gradient would be -4. So because our line is perpendicular to that, if we find the negative reciprocal of -4, that will tell us what the gradient of our line is. So it's -4, but we want to find the negative reciprocals. That means we change the sign, so it's now going to be positive. And the reciprocal of 4 is a quarter. So the negative reciprocal of -4 would be a quarter because we're changing the sign. So we're changing it from negative to positive, and we find the reciprocal of 4, which is a quarter. So our line will be y equals a quarter x, and then we've got plus c. Now, we know that passes through the point 0, 8, and 0, 8 is quite a nice point. It's 8 on the y-axis, 0, 8's there. So the y-intercept would be 8. So our line will be y equals a quarter x plus 8. And that's it. So y equals a quarter x plus 8. Okay, let's have a look at question number 4. So question number 4 says, write down the equation of the line that is perpendicular to 3x minus y equals 1 and passes through the point 0, 9. So it's the equation of the line, so it's y equals mx plus c. And we want to find its gradient and its y-intercept. Let's start off with its gradient. So if we look at the line that it's perpendicular to, we've got 3x minus y equals 1. Now, whenever I'm looking at this, I can't spot its gradient straight away, because if it was in the form y equals mx plus c, I can spot the gradient straight away, but this isn't y equals. I want this to be y equals. Now, if we have a look here, we've got 3x minus y equals 1. I'm going to add y to both sides of this equation. I'm going to add y to both sides, and that will give me, well, I'm adding y to get rid of the minus y, so it will leave me with 3x on the left-hand side. And on the right-hand side, I had 1 plus y, so that's 1 plus y. Now I want the y on its own because I want y equals something, so I'm going to -1 and -1, so that'll be 3x minus 1 equals y. So that means the equation of this line would be y equals 3x minus 1. I can now see that its gradient is 3. So for this line, we know its gradient is 3. So the gradient for this line is m equals 3. The gradient of this line is 3. Now for our line, it's perpendicular to it. So if we find the negative reciprocal of 3, then that will be the gradient of our line. So y equals, so it's positive, so we're going to make it negative, and the reciprocal of 3 is a third. So y equals minus a third x. So the gradient of our line is minus a third because that's the negative reciprocal of 3. And it passes through the point 0,9. So because it passes through 9 on the y-axis, it'll be plus 9. So it's y equals minus a third x plus 9. And that's it. Now this question was a bit trickier because whenever we were given the equation of the line that was perpendicular to, we didn't have it in the form y equals mx plus c. So sometimes you might need to rearrange it. Okay, let's look at question number 5. So question number 5, we've been given this diagram. We've got our x-axis and our y-axis. We've got this line A, which has got a negative gradient and passes through 5 on the y-axis, the point 0,5. And we've got the line B, which has got a positive gradient and comes up and goes through the point 0,5 as well. And the lines A and B are perpendicular, so they're perpendicular to each other. That means they cross at right angles, they're perpendicular. And if they're perpendicular, it means their gradients will times together to be -1, or we can consider the fact that the gradient of one is the negative reciprocal of the gradient of the other. And both lines pass through the point 0,5. So they both pass through the point 0,5, as you can see. And the gradient of line A is equal to -3/4. So for A, m is equal to -3/4. So we know the gradient of A, which is -3/4. Let's find the gradient of B. So m will be equal to the negative reciprocal of this gradient. Now this is negative, so when we find the negative reciprocal, that'll make this one positive. And as you know, it's positive because it's going upwards. And the reciprocal of 3/4 is 4/3. So that means that the gradient of this line is 4/3. So the gradient of this line is -3/4, and the gradient of this one is equal to 4/3. And then the question says, write down the equation of the line B. So we want to find the equation of this line B. So B, it'll be in the form y equals mx plus c. We know its gradient, so y equals 4/3 x. And in terms of the plus c, that's where it crosses the y-axis. It crosses the y-axis at 5, so that'll be plus 5. So that means the equation of the line B will be y equals 4/3 x plus 5. And let's write that down. Okay, let's have a look at question number 6. So question number 6 says a point A is the point 5, -2. So that's the point A. And we've got the point B, which is 11, 1. And we've been asked to find the equation of the line that's perpendicular to AB and passes through the origin. So if we find the gradient of AB, we can then find the gradient of the line perpendicular to it, considering the negative reciprocal. And we then know where it passes through the origin. So that means we can find the equation of that line. So what we need to do is we need to find the gradient of the line that passes through the points A and B. So here we've got our x and our y-axis, and A would be 5 across 2 down, so A would be here somewhere. So let's call that A. And B would be 11 across and 1 up, so B's up here somewhere. So the gradient of this line will be positive. So let's join them up, and we want to find the gradient of that line. So we want to work out our rise and our run. So A is the point 5, -2, so 5, -2, and B is the point 11, 1. So let's work out our run and our rise. So our run, we've gone from 5 across to 11 across. That means that our run will be 6 because we're going another 6 across. And we are, in terms of our rise, we're going from a height of -2 up to 1, so our rise will be 3. So to get the gradient of this line, so for this line, AB, we're going to do m equals rise over run, so rise over run. The rise is equal to 3, the run is equal to 6, so 3 over 6 is equal to a half. So the gradient of this line is equal to a half. Now, in terms of the question, we're trying to find the equation of the line that's perpendicular to this. So y equals mx plus c. It's perpendicular to this. That means that its gradient will be the negative reciprocal. So we're going to do y equals, and the negative reciprocal of a half, well, it's positive, so the negative reciprocal will be negative, and it's a half. So when we flip that over, we get 2 over 1, which is 2. So that's -2. So the negative reciprocal of a half is -2. So it'll be y equals -2x. And then in terms of our plus c, well, the line passes through the origin, so that means that it's going to be 0. Now, we're not going to write plus 0, so it'll just be y equals -2x. And that's it. Okay, let's have a look at our next question. Okay, let's have a look at question number 7. So question number 7 says the equation of 5 lines are given below. So we've got line A, line B, line C, line D, and line E. And we're asked which line passes through the point 20, 0. So remember, of a coordinate, we've got the x coordinate first and the y coordinate second. So we've got our, along the corridor and up the stairs, x and then y. So that means that x is equal to 20 and y is equal to 0. So if these lines, if we were to substitute in 20 for the value for x, do we get 0? And if we get 0, then we know it passes through the point 20, 0. So let's substitute x equals to 20 into each of these equations and see if we get 0 for the value of y. And if it does, then it passes through that point. So let's start off with line A. We've got y equals 4x plus 5. So that's 4 times x plus 5. X is 20, so y equals 4 times 20 plus 5. So y equals 4 times 20 is 80 plus 5 is 85. Well, that's not 0, so it doesn't pass through the line A. Line B, well, line B says y equals a quarter of x minus 5. So we need to do a quarter of x, so y equals a quarter of 20 minus 5. A quarter of 20 is 5, so we get y equals 5 minus 5, and 5 minus 5 is 0, so y equals 0. So actually that's right. So if we substitute in 20 into line B, we do get 0 for the value of y. So that means that it does pass through, this line does pass through the point 20, 0. Now let's just check with the others. Line C, we would have y equals 6 minus 20, because x is equal to 20. 6 minus 20 is equal to minus 14. So that line doesn't pass through the point 20, 0. It passes through 20 minus 14, so no. Our next one, line D, would have y minus, and then 4 times x is 4 times 20, which is 80, equals 1. Add 80 to both sides, we get y equals 81. That's not 0, so it doesn't pass through that line. And then finally, y plus 4x equals 6. Well, let's have a look and see if we substitute 20 in, do we get it to be equal to 0 for y? So if we had y, and then we do plus 4 times 20, which is 80, and that's equal to 6. If we take away 80 from both sides, we get y equals negative 74. And that's not 0. So that means that line B is the only one that passes through the point 20, 0. So which line passes through 20, 0? The answer is line B. Okay, part B. Part B says which two lines cross the y-axis at the same point. So in other words, which two lines have got the same y-intercept. So let's find the y-intercept of each of the lines. Now to that, what I'm going to do is I'm going to make y the subject for each of them, and then I can see the y-intercept really nicely. So here we can see this one has a y-intercept of 5. This one's got a y-intercept of negative 5, so they don't cross the y-axis at the same point. This one, I'm just going to change the order to y equals, and I'm going to put the x at the front, so it's minus x, and then the 6 is positive, so plus 6. So that crosses the y-axis at 6, so we've got one that crosses at 5, one that crosses at negative 5, one crosses at 6. Now let's have a look at this one. We want y equals, so we've got y minus 4x equals 1. If we add 4x to both sides of the equation, so add 4x and add 4x, we would get on the left hand side, we'd just be left with y. And on the right hand side, we'd have 1 plus 4x, or I could put the 4x at the front to write 4x plus 1. So that one is y equals 4x plus 1. So we've got this one crosses at 5, this one crosses at negative 5, this one crosses at 6, this one crosses at 1. Let's have a look at this last one, line E. So line E, we've got y plus 4x is equal to 6. We want the y on its own, so let's take away 4x and take away 4x. So take away 4x and take away 4x. And we get on the left hand side of y. On the right hand side, we'd have 6 minus 4x, so 6 minus 4x. And then we can move the minus 4x to the front, so we get y equals minus 4x, and the 6 is positive, so plus 6. So y equals minus 4x plus 6. Now, as you can see here, line C and line E both have a y-intercept of 6. So they will both pass through the point 0, 6. So part B, which two lines cross the y-axis at the same point? That would be C and E, and the point would be 0, 6. Okay, let's have a look at part C. Part C says which two lines are parallel. So if we go back up, we were looking for the lines that are parallel, so the lines that have got the same gradient. So let's have a look at their gradient. So for the first line, m would be equal to 4. For the second line, m's equal to a quarter. For the third line, m is equal to minus 1. For the fourth line, the gradient would be equal to 4, m is equal to 4. And for the last line, m is equal to minus 4. Now, as you can see, the gradient of line A and D are both equal to 4. So A and D are parallel because they've got the same gradients, so A and D. And finally, part D, which two lines are perpendicular? So we're looking for two gradients that would times together to be negative 1, or one where it's the negative reciprocal of the other. So if I had 4, the negative reciprocal of 4 would be, well, it's positive, so make it negative, and the reciprocal of 4 is a quarter. So the negative reciprocal of 4 would be minus a quarter. No. Okay, let's then look at a quarter. The negative reciprocal of a quarter, well, it's positive, so we're going to have a negative, and the reciprocal of a quarter is 4. So that's going to be negative 4. Oh, so the line B and E are perpendicular to each other, because as you can see, the negative reciprocal of a quarter is minus 4. And also you can check by doing a quarter times negative 4, and that's equal to negative 1. So because the two gradients times together to be negative 1, they're perpendicular. So let's write that down, B and E. And I better just check there's no other answer. So we've done A, we've done B. Let's have a look at C. Well, the gradient of C was equal to -1. The negative reciprocal of that, so it was negative, so let's make it positive. And the reciprocal of 1 is 1. So the negative reciprocal of -1 is 1. And none of the lines have got a gradient of 1. And then D, well, I had the same gradient of A. So the negative reciprocal of 4 was -1/4. And none of the lines have got a gradient of -1/4. And then we're left with our E, which the reciprocal of -4 will be 1/4. Okay, let's have a look at our next question. Okay, let's have a look at question 8. So question 8 says, on the grid below, the lines A and B are drawn. So we've got line A and line B. So we've got A and B. And the question says, are the lines perpendicular? Explain your answer. Well, we've got the two lines, but let's work out their gradients and see if they're perpendicular to each other. So let's start off with the line A. Okay, so if we look at this line A, to get the gradient of this line, we're going to choose two good points on the line A. So as you can see, it passes through here, this point, which is the point 6, 6, so it passes through the point 6, 6. And I'm going to choose another point. I'm going to choose this point here, and this point here is the point 12, 8. When I say good points, that's going to be coordinates where there are whole numbers for your x and your y value. So you're not sort of guessing like, this one is it, 11 and then 7 point something up. So these two would be good choices. Alternatively, we could have chosen 0, 4 or 3, 5 or 6, 6 or 9, 7 and so on. Okay, so we've got these 2 points on the line A and I want to work out its gradient. So I'm going to draw my little triangle with R and then our right angle. So we're going to draw the little triangle and then we're going to find the run and the rise. So in terms of the run, we're going from 6 across to 12 across, so it's got a run of 6. And in terms of its rise, it's going from a height of 6 up to 8, so it's going to rise of 2. So the gradient for this line for A will be m equals the rise over run, so rise over run. The rise is equal to 2. The run is equal to 6, and 2 divided by 6 is a third. So the gradient of this line is a third. So the line A has got a gradient of a third. Let's write that down. Line A, m is equal to a third. Okay, line B. Okay, now let's find the gradient of line B. So we want to choose some good points on this line. So we've got the point here, 0, 10. So that's the point 0, 10. We've then got the point 1, that looks like a decimal number, so I'm going to leave that one alone. 2, 5, so 2, 5 would be another one, so I'm going to choose those 2 points. I could have chosen 4, 0 also. So I'm going to draw the little triangle, so going across and down. And let's mark on the run and the rise. So the run, well, we're going 2 across, so the run would be 2. And then in terms of the rise, the line's going 1, 2, 3, 4, 5 down. So that means it's got a rise of -5. It's going down 5. So we want to find its gradient. So the gradient m is equal to rise, which is equal to -5 over the run, which is 2. And that would be m is equal to -5 over 2, or -2.5. So for line B, m is equal to -5 over 2. Now, straight away I can see that they're not perpendicular, because if they were perpendicular, the gradient of line B would have been the negative reciprocal of line A. So the negative reciprocal of a third, well, it'd be negative, and then flipping over a third would be 3. So the gradient of the line that is perpendicular to line A would be -3, and this line hasn't got a gradient of -3. And you could write that down. You could say line A has got a gradient of a third. For a line to be perpendicular to line A, it would have to have the gradient -3. So that means that line B is not perpendicular to line A. So that's one way we can show it. Another way we can show it is if two lines are perpendicular, the gradients will times together to be -1. So I'm just going to multiply these together and show that they don't equal -1. So I'm just going to do a third multiplied by -5 over 2. And remember, positive times a negative is a negative. So so far so good. If we want it to be perpendicular, it has to be -1. That's a negative. That's a positive. That's a good sign. And then let's multiply the numerators together and the denominators together. 1 times 5 is equal to 5. And then the denominator is 3 times 2 is equal to 6. And 5 over 6 isn't equal to 1. So that's not a gradient of -1. So therefore, line A and line B are not perpendicular, because, and that's it. So I've just said line A and line B are not perpendicular because their gradients do not multiply to give -1. And that's it. So there was a couple of ways you could have explained this question. You could have said, well, the two gradients don't multiply together to give you -1. You could have said, well, to be perpendicular to line A, it would need to have a gradient of -3, and line B doesn't have a gradient of -3. Alternatively, we could have looked at the gradient of line B, which is -5/2, and the negative reciprocal of -5/2 would be positive 2/5, and the line A doesn't have a gradient of 2/5. 2/5, so therefore they're not perpendicular. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 9. So we've got this line, this is a straight line L that's got equation y equals, so y equals minus a half x plus 2, and as you can see it's got a negative gradient and it passes through 2 on the y-axis, so fantastic. And we've been asked to write down the equation of a line parallel to L. So we want to write down the equation of a line, any line that's parallel to this line. Now remember, if two lines are parallel to each other, they'll have the same gradients, so we just want to write down a line that's got a gradient of minus a half. So let's do that. So y equals minus a half x. So we could just leave it like that because that's parallel to it. Y equals minus a half x, and that passes through the origin. I'm going to write plus 19 because y equals minus a half x plus 19. It still has a gradient of minus a half, and that's it. It's a line parallel to that line. Okay, let's have a look at part B. So part B says find the equation of a line that passes through the point 16 and is perpendicular to L. So we want to find the equation of the line that is perpendicular to this line and passes through the point 16. Now we know the gradient of the line L is equal to minus a half. So if we find the negative reciprocal of that, that will tell us the gradient of the line that is perpendicular to this line L. So we've got negative a half. We want to find the negative reciprocal of it. So if we change it to the negative reciprocal, it's now going to be positive because it was negative, so we make it now positive. And then we do the reciprocal of a half, which is equal to 2. So that means that the line with a gradient 2 would be perpendicular to this line. So we know it's going to be y equals 2x, and then we've got our plus c. So we need to find where it crosses the y-axis. So what we could do here is we could go to this point here, we could get our ruler and our pencil, and we could draw a line that has got a gradient of 2. So if it's got a gradient of 2, if we go across one unit, so from 1 to 2, we go up 2, would be there. If we go across another unit, so from 2 to 3 and go up 2, it would go to there. And then we can get our ruler and pencil, we can draw a line that passes through those points. And it would look something like that, because we've got a line that has got a gradient of 2. So that means we can now find where the line crosses the y-axis. And as you can see, it crosses the y-axis of 4. So that means the y-intercept would be 4. We've got y equals 2x plus 4. So that means the equation of the line that passes through the points 16 and perpendicular to L would be y equals 2x plus 4. And let's just check it. The gradient of the line we've been given was minus a half. We find the negative reciprocal of minus a half, that's 2. We know it passed through the point 16, so that means if we go across 1, up 2, across 1, up 2, or even across 1, down 2, we would find it passes through the point 4 on the y-axis. Now whenever you look at these two lines, they don't look perpendicular. You know, that doesn't look like a right angle. It's actually, well, it's not a right angle, that's not a right angle, that's not a right angle. And that's because of the scale of the axes here. This axis is going up in 1, 0, 1, 2, 3, and so on. And this axis is going up in 2, 0, 2, 4, 6, and so on. But if you were to draw these graphs out where you use the same scale, so you went up in 1s here, 0, 1, 2, 3, then they would be 90 degrees. And that's it. So if we have a look, the equation of the line that passes through the point 16 and is perpendicular to L would be y equals 2x plus 4, and that's it. So that was one way to do that question. Now there was another way to do it, and this other approach is really useful whenever the point we're given is really far away from the y-axis. That one was quite nice because it was 1 something, so we could figure out where across the y-axis quite nicely. So at this point here, when we had y equals 2x plus c, if we wanted to find the value for c, we could look at the coordinate that it passes through, and when that has a x coordinate of 1 and a y coordinate of 6, x and y, and if we substitute in 1 and 6 into this, we can find our value for c. So let's do that. So x is equal to 1 and y is equal to 6. So y, that's 6, is equal to 2 times 1, that's 2, plus c. And if we take 2 away from both sides, that's going to be 4 is equal to c. So c is equal to 4. So that means if we put our 4 back in, we would get y equals 2x plus 4. And that approach is really useful whenever the point we've been given is really far away from the y-axis, or maybe has decimal numbers and things like that. That can be quite a useful approach. Okay, let's have a look at question number 10. So question number 10 says the straight line K has got equation y equals 2x minus 5. And the straight line J is perpendicular to K and passes through the point negative 4, 8. So it's perpendicular to K and passes through this point. Find the equation of line J. So it's a straight line, so it's going to be in the form y equals mx plus c. And we need to find its gradient, and we need to find where it crosses the y-axis. So let's start off with its gradient. It's perpendicular to this line, and this line's got a gradient of 2. So that means that if we find the negative reciprocal of 2, that's the gradient of j. So the negative reciprocal of 2, well, it's positive, so the negative reciprocal will be negative, so it will be minus. And the reciprocal of 2, well, reciprocal of 2, that's 2 over 1. When we flip it over, it will be a half. So that means the gradient of j would be minus a half. So we've got y equals minus a half x, and then we've got plus c. So now we need to find the c, where it crosses the y-axis. Now if we have a look, we've been given a point that passes through, the point negative 4, 8. That means that x is equal to negative 4 and y is equal to 8. So if we substitute those into our y equals minus a half x plus c, we can find c, and then we'll know the gradient and where it crosses the y-axis, so that means we'll have our equation. So x is equal to negative 4 and y is equal to 8. So we've got y, so that's 8 is equal to, and then we've got minus a half x, that's minus a half times x, and x is minus 4, and then we've got plus c. So then we've got 8 is equal to minus a half times minus 4. Well, negative times a negative is a positive, and a half times 4, well, half of 4 is 2, so that's 2 plus c. And if we take 2 away from both sides, we're going to get minus 2 and minus 2. We then get that 6 is equal to c. So c is equal to 6, so it means that across the y-axis it's 6. Now we just need to substitute that into our y equals minus a half x plus c, so that would give us y equals minus a half x plus 6. And that's it. So the equation of the line J is y equals minus a half x plus 6. So to this question, what we done was we found the gradient of the perpendicular line by finding the negative reciprocal of the gradient of the line we were given. So we found the negative reciprocal of 2, which was minus a half. We then wrote minus a half x plus c, and then we substituted in the values for x and y of the coordinate we were given. That gave us our c, and then that gave us our equation. Okay, let's have a look at question number 11. So question number 11. A straight line L is perpendicular to the line y equals 2x plus 3 and passes through the point 10, 3. Find the equation of the straight line L. We know the straight line L will have equation in the form y equals mx plus c. Let's find its gradient and let's find its y-intercept. So in terms of its gradient, it's perpendicular to this line. This line's got a gradient of 2. So if we find the negative reciprocal of 2, that will be the gradient of the perpendicular line. So the negative reciprocal of 2, well 2 is positive, so the negative reciprocal will be negative, so y equals minus. And the reciprocal of 2 is a half, so minus a half. So the gradient of the line that is perpendicular to this line would be negative a half. And then we're going to write our x and then plus c. Now we know it passes through the point 10, 3, so x equals 10 and y is equal to 3. So if we substitute those into our y equals a half x plus c, we can then find our c. So y, that's 3, is equal to minus a half of x, and that's minus a half of 10, plus c. Then we've got 3 equals minus a half times 10, that's going to be minus 5, plus c. And adding 5 to both sides of this equation would give us that 8 is equal to c. So it means that c is equal to 8, so if we substitute that into our y equals minus a half x plus c, that's our equation. So y equals minus a half x, and then instead of plus c, it was plus 8, so plus 8. And that's it. Okay, let's look at question number 12. So question number 12, a straight line has got equation y equals 3x plus 2. Line B is perpendicular to this line, so its gradient is going to be the negative reciprocal and passes through the point 6, 5. Find the equation of line B. So it's going to be y equals mx plus c. We know then to find its gradient, we're going to find the negative reciprocal of 3. Well, 3 is positive, so the negative reciprocal will be negative, and the reciprocal of 3 is, well, 3 is 3 over 1. When you flip it over, that's 1 over 3. So a third minus a third, y equals minus a third x, and then we've got plus c. Now we'd have a look at the point, that's x and y, so if we substitute in x equals 6 and y equals 5 into here, we can find c. So let's substitute those in. Y, that's 5, so 5 equals minus a third times x, which is 6, and then plus c. Minus a third times 6, well a third of 6 is 2, so minus a third of 6 would be negative 2, so 5 equals minus 2 plus c. Add 2 to both sides, so add 2 and add 2, and we're going to get 7 equals c. So that means that our equation would be y equals minus a third x plus 7, and that's it. Okay, let's have a look at question number 13. So the question number 13 says the line L passes through the points minus 4, 0 and 2, negative 2. And the line M passes through the points 3, 8 and 2, 2. And we're asked, are the lines L and M perpendicular? Show your workings. So let's work out the gradient of each one of those lines. So I'm just going to do a little sketch to find out where the points would be. Tell me if we work out their gradients. So I'm just going to do little sketches. So here's an x-axis and a y-axis. Okay, so let's start off with the line L. So it passes through the points so here and the point 2, negative 2. So down here somewhere. So that's the point negative 4, 0 there. And this is the point 2, negative 2. So 2, negative 2. So let's turn it into a triangle. So let's go across and down, and let's work out the run and the rise. So to get from -4 to 2, we're going to have a run of 6. We're going to cross 6. And then in terms of the rise, we're going from 0 down to -2. So it's got a rise of -2. It's going 2 down. So to work out the gradient of this line, we would do the rise divided by the run. So we're going to do gradient m is equal to the rise, -2 divided by the run 6. And -2 divided by 6 would be -1/3. So the gradient of that line is -1/3. Now let's look at the line M. It passes through the points 3, 8, so 3 across 8 up, so up here somewhere, 3, 8, and the point 2, 2, so 2 across 2 up, 2, 2 would be there, 2, 2. And let's join them up, and let's do a little triangle. So let's work out our run and our rise. So our run, we're going from 2 across the 3, so that's got a run of 1, and its rise, we're going from a height of 2 up to 8, so that's got a rise of 6. So the gradient here would be m is equal to, so rise over run, so the rise is equal to 6, the run is equal to 1, 6 divided by 1 will be 6. So we now know their gradients. The gradient of line L is equal to -1/3, and the gradient of line M is equal to 6. Now, are these two lines perpendicular? Well, no, they're not perpendicular, and there's a few different ways we can show that. First of all, well, if we had the gradient of 6 and we found the negative reciprocal, okay, the negative reciprocal of 6, well, it's going to be negative, and then the reciprocal of 6 is a 6th. So the line that would be perpendicular to line M would have a gradient of -6th, and the line L doesn't have that gradient. So that's one way we know that they're not perpendicular. Alternatively, we could look at the line L. We could find the negative reciprocal of -1/3. Well, this is negative, so when we find the negative reciprocal, that'd be positive, and the reciprocal of 1/3 is 3. So the line that would be perpendicular to L would have a gradient of 3, and M doesn't have that gradient either. Or another way, and the way I'm going to show it is the two gradients, if they're perpendicular, will times together to be -1. And -1/3 multiplied by 6 is equal to, and 1/3 of 6 is equal to 2, so -1/3 of 6 would be equal to -2, and that's not equal to -1, so no. And that's it. So I've just said, no, to be perpendicular, the gradients need to have a product of -1, and that's it. Okay, let's have a look at question number 14. Okay, question number 14 says, the straight line L1 has equation y equals 4x minus 6. So this is the equation of L1, and the straight line L2 is perpendicular, so that's great, we can find its gradient, and passes through the point -10, 1, and find the equation of the line L2. So we need to find the equation of this line L2, so it's going to be in the format y equals mx plus c, because we know it's a straight line. Let's find its gradient. Well, it's perpendicular to this line, and the gradient of this line is 4, so let's find the negative reciprocal of 4. So it's negative reciprocal, it's positive, so negative reciprocal will be negative, and the reciprocal of 4, well, that's 4 over 1. When we flip it over, it'll be a quarter. So the negative reciprocal of 4 is -1/4. So it'll be y equals -1/4 x, so that's the start of the equation, and then we've got plus c. Now we just need to find the y-intercept of L2, in other words, where L2 crosses the y-axis. Now we know it passes through the point -10, 1, so x is -10 and y is 1. And if we substitute those values into our equation, y equals -1/4 x plus c, we can then find the c, and then we can then know our equation. So we've got y, which is 1, equals -1/4 x. So we're going to do -1/4 times x, and x is -10, and then plus c. So we're now going to have 1, and then we're going to multiply -1/4 by -10. This is a calculator question, so you could type -1/4 times -10, and that'll give you the answer of 5/2, or 5 over 2. Another way to do it is a negative times a negative is a positive, and we're going to do a quarter times 10, and a quarter times 10 would be 10 quarters. And 10 quarters, when you cancel it down, would be equal to 5/2, or 5 over 2. So we'd have 5 over 2 plus c. Now we don't want the 5 over 2 here, we want the c on its own, so we're going to take away 5 over 2 from both sides, so take away 5 over 2 and take away 5 over 2. Okay, so we now just need to take 5 over 2 away from both sides of the equation. The right hand side is quite nice, we're taking away 5 over 2 to just leave us with the c, so it gets rid of the 5 over 2, so we're just left with c on the right hand side. On the left hand side, to find out what c is equal to, we're going to do 1 take away 5 over 2. That's a calculator question, we could do 1 take away 5 over 2 in our calculator, that's one approach. Another approach is 5 over 2 is 2.5, so we're doing 1 take away 2.5, so that'll leave us -1.5, so that's another approach to get your c. Alternatively, you could do 1 take away 5 over 2, and 1 is equal to 2 halves, and we're going to take away 5 halves, and 2 halves take away 5 halves would be equal to -3 over 2 halves, and that's equal to -3 over 2. So we could have got that in a couple of different ways. We could have done 1 take away 5 over 2 on our calculator. Another way would have been to do 1 take away 2.5, so that's -1.5, or -3 over over 2 as a top-heavy fraction, or you could have just done it as a fraction and said, well, 1 is 2 halves. You're taking away 5 halves, that'll leave you with minus 3 halves. And then we can just put our c into our equation here. So that would give us y equals minus a quarter x, and then we've got our minus 3 over 2, so minus 3 over 2. And that's it. So that's the equation of the line L2. Okay, let's have a look at our next question. Okay, question number 15. So question number 15 says, a straight line passes through the points 5, 0 and 14, 6. So these 2 points. And we've been asked to find the equation of the line L that is perpendicular to AB. So it crosses AB at right angles and passes through the point 2, 9. Okay, so what we need to do first of all is to work out the gradient of this line. If we can work out the gradient of this line, this red line that's shown here for us that passes through AB, then we can then do the negative reciprocal to get the gradient of the perpendicular line, and then we can use the point to work out where it crosses the y-axis. That would help us find the equation. Okay, so let's find the gradient of this line. So let's draw a little right angle triangle. So let's go across and then up. So the run, we're going from 5 across to 14, so the run would be 9. And in terms of the rise, we're going from a height of 0 up to 6, so the rise would be 6. So to get the gradient of this line, the gradient m is equal to rise over run. So it's going to be the rise, which is 6, divided by the run, which is 9, and 6 over 9 simplified would be 2/3. So the gradient of this line is m equals 2/3. That's the gradient of this line. Now, we want to find the equation of the line that's perpendicular to that. So remember, to find the gradient of a perpendicular line, we just do the negative reciprocal. So if we've got 2/3 and we do the negative reciprocal, well, it's positive, so the negative reciprocal will be negative. And then we're going to do the reciprocal of 2/3, that'll be 3 halves. So that means the gradient of the line that's perpendicular to this red line would be minus 3 halves. So we know it's going to be y equals minus 3 halves x plus c. And we just need to now find where that crosses the y-axis. Now to find where it crosses the y-axis, we know it passes through the point C, which is 2, 9. So x equals 2 and y is equal to 9. So if we substitute those values of x equals 2 and y equals 9 into here, we can then find c, and then that would be our equation. So let's do that and see what we get. So y, which is 9, equals minus 3 over 2 times x, and x is equal to 2, so we're going to times that by 2, and then we're going to then do plus c. This is an uncalculated question, so we're going to have to do this without a calculator. So we've got 9 equals, and now we're going to do negative 3 over 2 times 2. There's a couple of ways we can do this. We can first of all consider as minus, instead of 3 over 2, minus 1.5 times 2, and minus 1.5 times 2 would be minus 3, and then plus c. So that's one way we could do it. Another way we could do it is if we had minus 3 over 2 times 2, well, that's 2 over 1. If we times them together, a negative times a positive is a negative, 3 times 2 is equal to 6, and then on the denominator, 2 times 1 is equal to 2. So we get minus 6 over 2, and minus 6 over 2 would be minus 3, and that's the same. So we now know that we've got 9 equals minus 3 plus c. So if we add 3 to both sides, so add 3 and add 3, we get 9 plus 3 is equal to 12, and on the right hand side, we added 3 to get rid of the minus 3, so we're just left with c. So c is equal to 12. So what's the equation of this line? Well, the equation of the line would be y equals, we know its gradient was minus 3 over 2x, and then plus c would be plus 12, and that's it. Okay, let's have a look at our next question. Question number 16. Okay, let's have a look at question number 16. So question number 16 says the point A has coordinates 9, 4, and the point B has coordinates 13, negative 16. I've been asked to find the equation of the line that's perpendicular to AB and passes through the midpoint of AB. Now I'm actually going to do a sketch here. So we've got our x-axis and our y-axis, and we've got the point A, which is 9, 4, so 9 across and 4 up will be there, so that's the point A, 9, 4. And then we've got the point B, which is 13 across and 16 down, so the point B would be down there somewhere. And we're trying to find the equation of the line that's perpendicular to AB, so let's join up A and B. So we're trying to find the equation of the line that's perpendicular to AB, so crossing it at right angles, that passes through the midpoint of AB. So let's first of all start off by finding the gradient of AB. If we can find the gradient of AB, we can then find the gradient of the perpendicular line. So let's start off by finding the gradient of AB. So let's draw a little triangle, so let's go across and down. And in terms of our points, well, we had the point A, which was 9, 4, and we've got the point B, which is 13 minus 16. So to get from 9 to 13, we're going to go across. The run will be 4. And then in terms of the rise, well, we're going from a height of 4 down to a height of 16. So the rise would be minus 20. We're going down 20 there. So the gradient of this line, the gradient m, will be equal to rise over run. The rise would be negative 20, the run's equal to 4, negative 20 divided by 4 would be minus 5. So the gradient of this line AB is negative 5. Now we want to find the equation of the line that's perpendicular to it. So perpendicular, it crosses at right angles and passes through the midpoint. So let's start off by looking at the equation of this perpendicular line. It's going to be y equals mx plus c. We know the gradient of this line AB is equal to -5, so we need to find the gradient of the perpendicular line. So it's going to be the negative reciprocal. So let's find the negative reciprocal of -5. So because it's negative already, when we find the negative reciprocal, that makes it positive, and the reciprocal of 5 is a fifth. So that means that our line, this line here, will have a gradient of a fifth. And if you have a look at it, it's got a positive gradient, and it's not as steep as the other line. So we've got y equals a fifth x plus c. Now we need to find c. So to find c, we need a point that the line passes through. Now it passes through the midpoint of AB, so we need to find the midpoint of these two coordinates. So we need to find the midpoint of A and B. Now in terms of this midpoint here, we know that it's in terms of its x-coordinate, well this one's 9 across and this one's 13 across, so this one's going to be in the middle, so this one's going to be 11 across, because in the middle of 9 and 13 is 11. And another way we could have done that is we could just done 9 plus 13, which is 22, and half it, which is 11. And in terms of the height of it, the y-coordinate of the midpoint, we need to find the middle of 4 and -16, so we could try and work that out, or another way to do it is to just add them together, so to do 4 plus -16, and then add them together and half it. So 4 plus -16, well 4 take away 16 is -12, and -12 divided by 2 is equal to -6. So the midpoint would be 11 minus 6. So the coordinates of the midpoint of AB would be 11 minus 6. Now we're going to use that to work out the c, because if we substitute those values in, the x-coordinate and the y-coordinate, into our y equals a fifth x plus c, we can then work out the c, and then that would help us find the equation of this line. So let's substitute the value for y in. Y was equal to -6, so we get -6 is equal to a fifth times by x, and x is 11, so a fifth times 11 plus c. Okay, so we've now got -6 equals, and we're going to do a fifth times 11, well it's going to be 11 fifths plus c. Now we want to get c on its own, so we're going to take away 11 fifths and we're going to take away 11 fifths. And if we take away 11 fifths from both sides, we can then work out what c is. So whenever we do that, we get, well, -6 minus 11 fifths is equal to -41 fifths. And on the right hand side, we'd just be left with c, because we're taking away 11 fifths to get rid of the 11 fifths. So that means that c is equal to -41 fifths. And that means we've got our equation. Our equation would be, if we put that back in, we would have y equals a fifth x, and then we've got our c, which is then -41 fifths. And that's it. And so our answer would be y equals a fifth x minus 41 over 5. And that's it. Okay, let's have a look at question number 17. So question number 17 says a straight line L is perpendicular to the line with equation 5x minus 2y plus 4 equals 0. And L passes through the point 5, -3. And we've been asked to find the equation of the straight line L. So here we've been given a line that is perpendicular to, but it's not in the form y equals mx plus c. So let's make y the subject of this to begin with, because if we make y the subject, we can get it in the form y equals mx plus c, and that's going to be quite useful. So let's do that. So we're going to make y the subject, and that's -2y, so I'm going to add 2y to both sides to begin with. So add 2y and add 2y. So when we add 2y to the left hand side, we'll just be left with 5x. We're adding 2y to get rid of the -2y, and so we'd just be left with then plus 4. And on the right hand side with 0 plus 2y is just equal to 2y. So we've got, let's switch this around, so we've got 2y equals 5x plus 4. Now we don't want 2y, we just want to make y the subject, so let's divide everything by 2. So if we divide everything by 2, we'd get 5 over 2 x plus 2. So y equals 5 over 2x plus 2. So that means the gradient of this line is 5 over 2. Now L is perpendicular to that. So if we've got 5 over 2, when we find the negative reciprocal, it's positive, so we're going to make it negative, and find the reciprocal will be 2 fifths. So that means that L has got the gradient of -2 fifths. And now we need to find the equation of L, so y equals mx plus c. Y equals, the gradient is -2 fifths, so -2 fifths x plus c. It passes through the point 5 minus 3, so x is equal to 5 and y is equal to 3. If we substitute those in to our equation, we can get our c. So y is -3, so we've got -3 equals -2 fifths times x, so we've got -2 fifths times 5 plus c. Now 2 fifths of 5 is 2, so -2 fifths of 5 will be -2. So we've got -3 equals -2 plus c, or you could have just typed in -2 fifths times 5 in your calculator and you'll get -2. Now we've got here then -3 equals -2 plus c. Let's add 2 to both sides, so add 2 and add 2, and we'll get -3 plus 2 will be -1 equals c. So c is equal to -1. So we substitute that back into here, we'll then get our equation. Y equals -2 fifths x, and then instead of plus c, we'll have -1, so -1. And that's it, that's our equation. Okay, let's have a look at question number 18. So question number 18 says the line A has got an equation y equals minus 2/3 x. And line B is perpendicular to that, and it passes through the point 4,15. And then we're asked to find the coordinates of the point where the line B intersects the x-axis. In other words, where does the line B cross the x-axis? Let's start off by finding the equation of line B to begin with. That's going to help us find where it crosses the x-axis. So we know that it's perpendicular to A, so it's perpendicular to A. The gradient of A is equal to minus 2/3. So we're going to find the negative reciprocal of that. It's a negative, so when we find the negative reciprocal, that make it positive. And then whenever we find the reciprocal of 2/3, that's equal to 3/2. So that means the gradient of line B is equal to 3/2. So it's going to be y equals 3/2 x plus c. Now it passes through the point 4,15, so x is equal to 4 and y is equal to 15. So let's substitute those in and we'll find our value for c. So we've got 15 equals, then we've got 3/2 times x, that's 3/2 times 4 plus c. Now whenever we work out 3/2 of 4, well, we divide by the bottom and times by the top. 4 divided by 2 is equal to 2, times 3 is equal to 6, or another way to think of it is 1.5 times 4 is 6 as well. So we've got 15 equals 6 plus c. Take away 6 and take away 6 gives us 15, take away 6 is 9. So c is equal to 9. So we now know that the line B has got equation y equals 3/2x plus 9. Now we're asked to find the coordinates of where that crosses the x-axis. So let's do a little sketch. Okay, so let's sketch this graph and see what it would look like. So we've got our x-axis and y-axis, and we know it's got a positive gradient, so it's gone up this way, and it crosses the y-axis at 9. So it's going to look something like that, where it crosses at 9. So let's actually just label that. That's the line LB, so it crosses at 9, and it's y equals 3/2 x plus 9. And we want to find the coordinates of this point here, where it crosses the x-axis. So we want to find the coordinates of this point. Now, with all the points on the x-axis, they've all got a height of 0. They're all like, 4 across 0 up, 10 across 0 up, minus 4 across 0 up, and so on. So we know that all of the coordinates will be in the form of something 0. So in other words, we've got x and y, we know that y equals 0. So we know that whenever we want to find where a graph crosses the x-axis, we let y equal 0. So if we look at our equation, we've got y equals 3/2x plus 9. If we want to find where that crosses the x-axis, we let y equal 0. So we're going to write 0 equals 3/2x plus 9. Now we just need to solve this to find out the value for x. So we want to get x on its own, so let's take away 9 and take away 9. So that would give us minus 9 is equal to 3/2x. And so let's write that up here, 3/2x is equal to minus 9. Now at this point we've got a couple of approaches we can use here to do this. Now it's a non-calculator question, so we need to divide both sides by 3/2. So divide by 3/2 and divide by 3/2. So 3/2x divided by 3/2, well that's just going to be x. On the right hand side we need to do negative 9 divided by 3/2. So we've got negative 9, so we've got negative 9 or 9/1, and we're going to divide that by 3/2. Now whenever we're dividing by a fraction, we multiply by the reciprocal, so we've got negative 9/1 multiplied by 2/3. Well, a negative times a positive is a negative, and then we've got 9 times 2 is 18 over, and then we've got 1 times 3 is equal to 3. So we've got minus 18/3, and 18 divided by 3 is 6, we've got minus 6. So that means that x equals minus 6. Or another way we could have done this question is, because we've got 3/2, that's 1.5, and we could have just divided minus 9 by 1.5, and 9 divided by 1.5 is 6, so minus 9 divided by 1.5 would be minus 6. Now the question says write down the coordinates of the point, so the coordinates of this point would be minus 6, 0, and let's just write that down, minus 6, 0. And that's it. Okay, let's look at question number 19. Okay, question number 19 says, shown below are straight lines A, B, and CD. So A, B, and CD are straight lines. And then we're told that M is the midpoint of CD. So M is the midpoint of CD. AB is perpendicular to CD and passes through M, so it passes through the midpoint. We're told that C is the point with coordinates 0, 12. So let's write that on, 0, 12, that's the coordinates of the point C, and D is the point with coordinates 3, 0. So there's those points, and we've been asked to find the equation of the line AB, so we want to find the equation of this line. Now M is the midpoint of these two coordinates, so I'm actually going to find the coordinates of this midpoint. So to find the coordinates of the midpoint, what we're going to do is I'm going to add the coordinates together and half them. So 0 plus 3 is equal to 3, and half it would be 1.5 or 3/2, 1.5 or 3/2. And in terms of the y coordinates, we've got 12 plus 0, 12 plus 0 is 12, divided by 2 is 6. So the coordinates of the point M would be 1.5, 6, or 3/2, 6. So we've now got these coordinates, and we want to find the equation of the line AB. So we know it's perpendicular to CD. Now we can find the gradient of CD quite nicely. So let's find the gradient of CD. So let's do our triangle, so go across and down. So in terms of our run, we're going from 0 across to 3, so we're going 3 across. And in terms of our rise, we're going from a height of 12 down to 0, so the rise would be minus 12. So to get the gradient of this line, we're going to do rise over run. So for CD, we've got m is equal to the rise, which is minus 12, divided by the run, which is 3, and minus 12 divided by 3 would be minus 4. So the gradient of this line, CD, is minus 4, so m equals minus 4 for this line. Now let's find the gradient of AB, because we're trying to find the equation of AB, so let's find the gradient of it. So it's going to be the negative reciprocal, so let's find the negative reciprocal. The gradient's a negative, so when we find the negative reciprocal, that'll make it positive, and the reciprocal of 4 is a quarter. So that means the gradient of this line AB is a quarter. So that means the equation of the line AB will be y equals a quarter x plus c, and we just need to find the c where it crosses the y-axis, this point, and then that will give us the equation. Now we need a point that it goes through. Now if you notice, the line AB is perpendicular to CD and it passes through M, so it passes through this point. So we know that x equals 1.5 or 3 over 2 and y equals 6. So let's substitute those in and see what we get. So we've got y, which is 6, so 6 equals, and then we've got a quarter of x, or a quarter of x. Now here we've got a quarter of x. Now instead of 1.5, 1.5 is the same as 3 halves. So I'm actually going to change my x back to 3 halves, just so that whenever I'm multiplying the fractions here, it just makes it a bit easier. And then plus c. So I've just substituted in 3 halves for x, and I've substituted in 6 for y. Now let's multiply and see what we get. So timesing these together, so we've got 6 equals a quarter multiplied by 3 halves. 1 times 3 is equal to 3, and 4 times 2 is equal to 8, so 3/8 plus c. Now we're almost there. We want to find out what c is, so we need to then get c on its own. So let's take away 3/8 from both sides of this equation. So take away 3/8 and take away 3/8. On the right hand side, we've got 3/8. We're taking away 3/8, so we're just left with c. On the right hand side, we had 6, so we've got 6 take away 3/8. Now we can do this in two different ways. We could say that's 5 and 5/8. That's one way we can do it. Alternatively, we could do it as a top-heavy fraction. So we could write it as a fraction with 8 on the denominator. So with 8 on the denominator, we would multiply, if we had 6 over 1, we'd times both of those by 8. 6 times 8 is equal to 48, and then 8 on the denominator. So 48/8 is equal to 6. So we've got 48/8, take away 3/8 would be equal to 45/8. So that means that c is equal to 45/8. Let's write down the equation of the line AB. Well, I had a gradient of a quarter, and we wanted to find the y-intercept, so we've got y equals a quarter x plus 45 over 8. And that's it. So that's the equation of the line AB. Okay, let's have a look at our next question. Okay, let's have a look at question number 20. So question number 20 says the point A has got coordinates 311, the point B's got coordinates -9,7, and the point C's got coordinates -7,1. And we're told that Luna says the angle ABC is a right angle. Show that Luna is correct. So the first thing I'm going to do here is I'm going to draw a set of axes, x and y axes, and I'm going to plot these 3 points and label them. And it would look something like this. So I've got our x-axis and our y-axis. We've got the point A, which is 311, the point B, which is -9,7, and the point C, which is -7, so not quite as far away as B, and up to 1. And then what Luna says is the angle ABC is a right angle. So let's join those up. So let's join up A and B, like so. And let's join up B and C like so. And she says this is a right angle, and actually we're asked to show that it's correct, so this is a right angle. So we want to show that this is a right angle in here, so this angle here. And to show that this angle is a right angle, we're going to show that the line BA is perpendicular to the line BC. And if we can show that the line BA is perpendicular to the line BC, that means this is a right angle. So what we're going to need to do is find the gradient of the line BA to begin with, and then we need to find the gradient of the line BC, and then we can then hopefully show that they're perpendicular to each other. So let's do that. So let's do our rise over run. So let's find the gradient of BA. So let's go across from B all the way across to where A is, and then we'll go up to A, and then that's a right angle triangle. Let's find our run. We're going from -9 across to 3, so it's got a run of 12. And in terms of the rise, we're going from a height of 7 up to a height of 11, so it's got a rise of 4. So we've got a triangle that's got a run of 12 and a rise of 4. So the gradient M is equal to rise over run. So that's going to be the rise, which is 4, over the run, which is 12. And 4 over 12, if we simplify it, would be 1/3. So the gradient of the line BA is equal to 1/3. So the gradient of BA is 1/3. Now let's find the gradient of the line BC. So we need to find the gradient of this line BC. So to do that, let's do our little triangle again. And we're going to start at B and we're going to go across and then we're going to go down to C. So like so. So we've got our little right angle triangle. So in terms of our run, we're going from -9 to -7. So it's got a run of 2. We're going 2 across. And then in terms of our rise, we're going from a height of 7 down to a height of 1. So the rise, because we're going down, it's going to be negative, and we're going down from 7 to 1. So it's got a rise of -6. So we want to find the gradient of this line. So we're going to do rise over run. So the gradient of the line BC would be m, and that is equal to rise over run. The rise is -6, the run is 2, and when we do -6 divided by 2, that's -3. So the gradient of the line BC is -3. Let's write that down. Now we want to show that these two lines, BA and BC, are perpendicular to each other, and if we can show that BA and BC are perpendicular, that means that's a right angle. Now to show two lines are perpendicular to each other, I like to multiply them together and show that that equals -1. So let's take the gradient of BA, so a third, and let's multiply that by the gradient of BC, which is -3. And when we do a third times -3, well, a third of 3 is 1, and a third of -3 would be -1. So a third times -3 would be -1, and that's it. So we're showing that the two lines are perpendicular. So let's write that down. So I've written down as the gradients of BA and BC multiplied together to give us -1, the lines are perpendicular. So that means that angle ABC is 90 degrees. And that's it. So Luna is correct. Okay, let's have a look at question number 21. So question number 21 says the points A, B and C have coordinates 2, 9, 10, -7 and 6k respectively. And we're told that AB is perpendicular to AC. Find K. So let's do a little sketch and see what it looks like. So I've plotted the points for A, which is 2, 9, and the point B, which is 10, -7. And in terms of the point C, it's got coordinates 6k. Now we don't actually know the K, so we know it's 6 along. So it's going to be in between the A and the B. It's going to be here somewhere. And let's see if we're going to be up here somewhere, or down here somewhere. And we don't actually know where it is yet, but let's see what we can find out. We know that AB is perpendicular to AC. So let's join up A and B together. So AB is there. So that means AC, so whenever we join up A to C, so I'm thinking up here somewhere, that this is a 90-degree angle because we're told that AB is perpendicular to AC. So I think the point C must be up here somewhere, so this is going to be a right angle. If I had done my point C down here somewhere, then that wouldn't have been a right angle in there because AC is perpendicular to AB. So let's actually just move our right in here. So we've got the points A, 2, 9, we've got the point B, which is 10, -7, and the point up here, C, is equal to 6, and then K, a particular height which we're trying to find. And we know that this is a right angle. So in this question we're told that AB is perpendicular to AC. So if we can find the gradient of AB, we can work out what the gradient of AC would be because they're perpendicular. We can find the negative reciprocal. Once we know the gradient of this line, we can then work out the value for K. So let's do that. So let's find the gradient of AB to begin with. So let's go across, let's draw a triangle going across and down. So in terms of the run, we're going from 2 across to 10, so it's going to run of 8. And in terms of the rise, we're going from 9 down to -7, so it's going to have a rise of -16. We're going down 16 here. So to find the gradient of this line, we're going to do the rise divided by the run. So we're going to do -16 divided by 8. So that means that the gradient of AB would be equal to -16 divided by 8, which would be -2. So the gradient of this line, AB, is -2. So that means we can find the gradient of AC. The gradient of AC will be the negative reciprocal of this. Now it's already negative, so when we do the negative reciprocal, that make it positive, and the reciprocal of 2 is a half. So that means the gradient of AC is equal to a half. So that means the gradient of AB is equal to -2, and the gradient of AC is equal to a half. Now we know the gradient of this line is equal to a half, we can work out the value for K. So I've just drawn a sketch of the points A, C. So we've got the point A, which is 2, 9. We've got the point C, which is 6K. So that's this part of this diagram. I've just drawn it here. And we know the gradient of this line is equal to a half. So let's actually look at it and let's find the rise and the run if we can. So let's draw a little triangle. So going across and up. And in terms of this diagram, well, we can find the run. We know we're going from 2 across to 6. We're going from 2 across to 6. So that means the run will be equal to 4. So the run's equal to 4. And the rise is what we're trying to find. Let's just call that the rise just for the moment. And we know the gradient of AC is equal to a half. So that means that whenever we work out the gradient, we do rise over run. So the rise divided by 4 will be equal to a half. And that means that if we multiply both sides of this by 4, we can find the rise. So if we times by 4, and times by 4, we get that the rise would be equal to, well, a half times 4 would be equal to 2. So the rise is going to be equal to 2 here. So we know the point A had a height of 9, so if we go up 2, that means that K must be 11. So that means that the value of K is equal to 11, and that's it. So K is equal to 11. Okay, let's have a look at our next question. So question number 22. Okay, let's have a look at question number 22. So question number 22, we've been given this diagram and we've got the points A, which is -9, 3, the point B, which is 11, 8, and we've got this point P, and we're told the straight line L passes through the points A and B. And the point P lies on this line such that the ratio of A to P to B is equal to 3 to 2. So in other words, if this distance was 3, this distance would be 2. If this distance was 6, this distance would be 4, and so on. And we've been asked to find the equation of the line that's perpendicular to L, so perpendicular to L and passing through P. So there's going to be a line that's perpendicular to the line L that passes through P, and we need to find its equation. So let's start by finding the coordinates of the point P. So I'm going to use this information, this ratio, to find P. And what I'm going to do first of all is find how do we get from A to B. Because then if we know how to get from A to B, we can then use this ratio to find out how to get from A to P and then find the coordinates of P. So let's go the whole way from A to B. So if we went from A to B, we'd be going across horizontally to begin with and then up. And we'd be going across from -9 all the way to 11. So we'd be going across 20. And then we're going from a height of 3 up to 8. So we're going up 5. So we know to get from A to B, we would go across 20 and up 5. Now we can use this ratio to figure out how to get from A to P, because we know the whole distance would be, well, 3 plus 2 is equal to 5. So if I divide these distances by 5 and then times them by 3, that would tell us how to get from A to P. So let's divide 20 by 5, so do 20 divided by 5, that's equal to 4, and then times it by this number in the ratio, the 3, the distance from A to P, so 4 times 3 is equal to 12. So instead of going 20 across to get from A to P, we're going to go 12 across, so we're going to go 12 across. So 12 across. So because the point A had an x coordinate of -9, we're going to go 12 across. So -9 add 12 would be 3. So that means it will be 3 across for this point P. And then in terms of the rise, well, the whole rise is 5. Well, we divide that by 5. So 5 divided by 5 is equal to 1. And we're going to times that by that number in the ratio of 3. So 1 times 3 is equal to 3. So if we want to go from A to P, we would go across 12 and we would go up 3. Now, the point A had a height of 3. We're going to go up another 3, so that would be 6. So, I mean, the coordinates of the point P would be 3, 6. And that's going to be really useful. Now, we can just find the equation of the line that's perpendicular to AB. So, we're going to find the gradient of AB. We'll find the gradient of the line that's perpendicular to that, and we know it passes through the point P, which is 3, 6. So, now we want to find the gradient of this line L that passes through A and B. Now, what's great is we've got these distances, the 20 and the 5. That's the run and the rise. So, in terms of the line L, its gradient M would be equal to the rise divided by run, so rise over run. The rise is equal to 5, so we've got 5, and the run is equal to 20. So if we do 5 divided by 20, that's equal to a quarter. So the gradient of that line is equal to a quarter. So we want to find the gradient of the line that's perpendicular to that. So that's going to be the negative reciprocal of this. So if we had a quarter and we work out the negative reciprocal, well, that's going to be negative because it's positive. We're going to make it negative, and the reciprocal of a quarter would be 4. So that means the gradient of the line that's perpendicular to this line L would be -4. So let's work out this equation. We've got it's y equals -4x plus c, because it's y equals mx plus c, and we know its gradient was -4, and it passes through the point 3, 6. So we know that x equals 3 and y equals 6, so we can substitute those in and find the value for c. So let's substitute those in and see what we get. So instead of y equals, we're going to have 6 equals, so 6 equals. Then we've got -4 times x, and x is equal to 3, so -4 times 3 is -12, and then we've got plus c. We want to find the value for c, so we're going to add 12 to both sides here, so we're going to add 12 and add 12. 6 plus 12 is equal to 18, and on the right hand side we added 12 to get rid of the -12, so we'll just be left with c. So that means that the equation of this line would be y equals -4x, and then we've got plus 18. So that's the equation of the line that's perpendicular to L and passes through the point P. So that's it, that's our answer. Y equals -4x plus 18. Okay, let's have a look at our next question. Okay, let's have a look at our last question. So question number 23. So shown below are two straight lines. So we've got two straight lines. We've got line 1 and line 2, and they've been drawn on this grid. And the question says line 1 has got equation 3x minus 12. So line 1, this line here, has got equation y equals 3x minus 12. So that's the equation of line 1. And then the question says find the equation of line 2. So we want to find the equation of this line here. Now, whenever we have a look at this question, the first thing that I notice is the axes, the x-axis and the y-axis, the x-axis and the y-axis, they don't have any scales. We don't actually have any numbers written on them. We have the origin, so this is the origin, but we don't know where this line crosses the x-axis or where this line crosses the x-axis, or we don't know the y-intercept for this line and so on. But we do know the equation of the line 1. Line 1 has equation y equals 3x minus 12. Now if we have a look, minus 12 is the y-intercept. That minus 12 tells us where that line 1, crosses the y-axis. It crosses at minus 12. So if we go down here, this point here must be minus 12. Now if we know this point's equal to minus 12, that means that this point here would be minus 6 because it's halfway to the origin. That must be minus 3, that must be minus 9 and so on. So that means that we're going up in threes. And that means that then this would be 0 here, the origin, then we've got here 3, this would be 6, this would be 9, 12, 15 and so on. So we've got the scale for the y-axis, and we're going up in threes. Let's now find the scale for the x-axis. So whenever we have a look here, we have got our equation of our line y equals 3x minus 12. And we want to find where this line crosses the x-axis, because if we know what this point is, we can then figure out the scale for the x-axis. Now we know that whenever a line crosses the x-axis here, that its height is 0. We know y equals 0. So if we want to find where it crosses the x-axis, we let y equals 0. So we've got the equation y equals 3x minus 12. If we let the height y equals 0, we'd have 0 equals 3x minus 12. If we add 12 to both sides, so add 12 and add 12, we get 12 equals 3x. And divide by 3 and divide by 3. 12 divided by 3 is 4, so we get 4 equals x. So that means it crosses the x-axis at 4. So that would be 4. That would then be 2. That's 0. So we're going up in 2's here. So 6, 8, 10, 12, 14, 16, 18, 20, and so on. So we now know for line 2, it crosses the y-axis at 6 and the x-axis at 18. So we can find the equation of this line because we know 2 points it passes through. And the question says, find the equation of this line. So we need to find the equation of this line 2. So let's find the equation of it. So let's do our little triangle to get its gradient to begin with. So let's go across and then down. So we've gone across the run where we're going from 0 all the way to 18. So its run will be 18, and its rise where we're going down from 6 to 0. So its rise would be negative 6. So for the gradient of this line, line 2, so for line 2, this line here, m would be equal to the rise, which is negative 6, divided by the run, which is 18. And 6 over 18, well, if we cancel down 6 18s, that's a third, but it's negative 6 over 18, so it's going to be minus a third, so minus a third. So the gradient of this line 2 is minus a third. And it crosses the y-axis at 6, so that means its y-intercept is 6. So that means the equation of this line 2 would be y equals minus a third x plus 6. And that's it. So the equation of this line 2 would be y equals minus a third x plus 6. And that's it. So that's part A. Find the equation of line 2, y equals minus a third x plus 6. Okay, let's have a look at part B. Part B says, are the two lines perpendicular? Well, if they're perpendicular, their gradients will multiply together to give us negative 1. So the gradient of line 2 is minus a third. So we've got minus a third. And then if we multiply that by the gradient of the other line, which was 3, let's see what we get. So we've got minus a third times 3. Well, a third times 3 is 1. So minus a third times 3 would be minus 1. So the gradients do multiply together to give us minus 1. So that means that they are perpendicular. So let's write that. So I've written, as the products of the gradients is minus 1, they are perpendicular. So yes, they are perpendicular because the two gradients times together to be negative 1. And that's it. So these have been the video solutions to the perpendicular line practice questions on Corbettmaths Maths. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to the YouTube channel. If you need any extra help on perpendicular lines, there's a video tutorial on Corbettmaths Maths, video 197. And if you go to corbettmaths.com/content, so you scroll down to video 197, there's a video tutorial there on perpendicular lines. Now going through this video, it can also be useful to find the equation of a line, so watch that video as well. Also watch the video on parallel lines, it's useful to know that as well. And yeah, I really hope you found this video useful. Thank you. Cheers. Bye.